Well, good morning, everyone, and thank you for joining. Welcome to this Core Telecom hosted webinar by Positron Access Networks. I'm sorry, the title is Deliver Top-Notch Broadband to Brownfield MDUs. I'm Lyle Frank. I've been with Core the past 13 years. And of note, Core is celebrating our 25th year this year. So again, thank you for your support in keeping our business going. Before I introduce our speaker, you will be muted during the event, but please, we welcome any questions at any time. Please submit them via the question function. On the top right of your screen, you should see a bubble with a question mark in it. So please submit your questions there, and we'll try to answer them as we go while we're on topic. So we look forward to those. Positron Access and Core have been partnered together for many years, I think even going back to the Sonic Multiplexor days, but more recently, we had really great success with our clients, many of you, with their BRX XDSL extender solution. And as 100 gig symmetrical, or I'm sorry, as 100 megabit and higher symmetrical speeds were being required, Positron has recently introduced their gigabit access multiplexor, we call the GAM, to provide up to Gig-E symmetrical speeds over existing twisted pair and coax networks, which is what we'll be reviewing today. So let me introduce Jim Staley. He's Senior Vice President of Global Partnership Management at Positron. He's had many years in the industry, like myself. We shared some time at AFC, but I don't think at the same time. Jim was also with Calix and has had a lot of experience with both copper and fiber PON and active networks. So Jim, take it away.
Thanks, Lyle, and welcome everyone. Thanks for attending. Keep in mind this is the general overview of the technology. I won't get too deep. I'll stay high level. And then if there's additional interest and questions, we'll get some questions at the end. And you can also sign up with your account manager from Core. You can sign up for an individualized presentation to go over the specific challenges that you have in your networks with respect to multi-dwelling units and multi-tenant units that need higher speeds, but it might be too expensive or take too long to rewire them. Because that's what we do. So the key takeaways of the presentation is one slide. Who is Positron is one slide. What is G.hn, which is the technology that our G.hn Access Multiplexor, the GAM, utilizes. What market segments, why would you use it and where would you use it? The GAM, the solutions family, the family picture, some application examples, how we partner up with software support, integration, and so forth. And then, of course, questions and summary. I love to get questions in the middle, though, so if you submit them to Lyle, he'll wake me up or stop me, and I'll answer those questions. All right, first off, we know that most of you on this phone are highly focused on getting fiber as many places as you can in your network, and we applaud that effort. Fiber is king, fiber is permanent, and once you get fiber to a unit or inside a unit, we know, and you're done. Well, I mean, you may have different electronics hook up to it from time to time, but you shouldn't have to put new fiber in ever, unlike copper and coax. That said, we completely understand the difficulty of extending the power of that fiber, the bandwidth of that fiber throughout a multi-dwelling unit. It's fairly easy to drill a hole and fish some fiber through a single family home, maybe even a duplex. But once you get into those larger structures, getting the fiber throughout the building, if it was built in the 1960s, 70s, 80s, and so forth, it can be difficult. And what's inside the walls of those buildings is what you see on this screen here, the copper twisted pair telephony cable, and then the coaxial cable that was typically installed by the local cable company years ago. And it's Cat3 for the twisted pair, usually. Sometimes it's worse. Sometimes you get lucky and it's Cat5. Very rarely, if it's an older building, do you get Cat6, which is what you'd really like as a Band-Aid if you don't have fiber. And then the coax is typically RG59. So what our multiplexor does, what we do with Core, is we extend the power of your fiber, that fiber that you've got going down the street passing that building. We extend the power of that fiber inside the multi-dwelling unit, the multi-tenant unit, business, residential, campus, mid-rise, high-rise, garden style, no matter what it is. We do that without the extra cost, the time, and the mess of rewiring. Positron, as Lyle mentioned, has been working with Core for a long time. We've been around for 50 years. We're not a new company. This is just a new product from an existing company that's private and profitable and cash flow positive. So you don't need to worry about us, and you don't need to worry about Core. We're stalwarts in the industry. You don't need to worry about support or either one of our companies disappearing. That's just the point of this slide. So for those of you who haven't heard about the technology, this is what it is. G.hn stands for Gigabit Home Networking. It was developed under ITU specification 9660, G.9660. And so just like over the years, as I worked for Calix, we went from BPON to GPON to XGS-PON. While Adtran and Nokia were doing the same thing, G.hn has gone through the same evolutionary path. I believe it's on its third chipset iteration, and it's a 2 gig chipset, and it's called Wave 2. So each G.hn chipset supports 2 gig per port. That's where we are today. There's a little bit of overhead in protocol. You'll see me mention 1.7 gig pure rate throughout the presentation. That's what you get out of each port effectively, is 1.7 gig, which can be configured symmetrically to provide symmetric gigabit service. So the magic around G.hn is how dynamic it is, how it enables symmetric gigabit services over Cat3 copper twisted pairs and up and down. And as a way of giving you more information, we actually had one customer hook G.hn up to barbed wire. We told them it could work on twisted pair. They hooked it up to barbed wire. They got several hundred megabits. So just know it's a twisted pair copper enabler from barbed wire to Cat6. And from RG59 to all the way up to RG6 and the thumb thick stuff you find out there in some RV parks and trailer parks and so forth. So the G.hn technology enables gigabit services over the existing copper and coax at symmetric gigabit speeds. And then the chipset that we use today is typically mixed with an Ethernet switch. So you get this feeling, I'll talk about it multiple times, where G.hn is the meat in the middle of an Ethernet sandwich. So we're just using a magical technology for that very last few feet of copper and coax, and then we're converting it back to Ethernet for your routers and switches and residential gateways and Wi-Fi access points and so on. There is a future for the technology that supports multi-gig. So the next chipset planned for next year is going to be 5 gig on the copper twisted pair and 10 gig on coax. So we'll be able to provide a new multiplexor to really go within these buildings, prevent the need for, again, trying to rewire them and go to multi-gig services. The rate reach are the next couple slides. And first, I'll show you copper twisted pair, and then I'll show you coax. On this one, you're seeing our performance over Cat3 twisted telephony wiring. We simply bought a reel of it, rolled it out all the way up onto our rooftop at our headquarters. And on a single pair, that's the blue line, we call it the SISO mode, single input, single output. We got a gig all the way out to about 150 meters or about 450 to 500 feet. In fact, it's better when you stretch it out than it is if you try to leave a coil of copper twisted pair in a box and measure the speeds on that. You'll get poorer speeds with that coil than you will if you stretch it out and go out a few hundred feet. What you want to know is that every G.hn Access Multiplexor, every GAM supports multiple ports of G.hn, and every port that supports copper supports SISO, single input, single output, single pair, or MIMO. That's the green line. That's multiple input, multiple output. That's 2 pairs. So if you've got 2 pairs between the GAM and the unit where you're trying to provide broadband, you can go out to 250 meters or as much as 800 feet of of gigabit. Now, while it's dropping along these distances to about a gig where I put the stars, it doesn't mean you can't provide symmetric gig, because we arbitrate between upstream and downstream. So if you have a gig throughput, you could provide a symmetric gig service, and then that customer using 100 megabits will never know that they're only getting a total of a gig. When they do a speed test, they won't know. They'll get a gig download, and then it'll arbitrate and quickly switch to upstream, and then they'll get a gig upstream. So you can provide symmetric gig service even when you're getting less than 2 gig from the GAM to the subscriber in total. And typically they're never going to know unless there's more than one subscriber trying to do a speed test on the same port at the same time, which is not possible with copper twisted pair because it's going to be a home run. The reason I mention it though is because it is possible to use splitters with coax. And so you could have multiple subscribers on a single coaxial port with splitters accessing and doing speed tests and so forth. So then you want to pay attention to your oversubscription ratios and your speed tests. On coax, you can see you can get much further distances. You can get, yes, sir.
Jim, I'd like to break in before you get too deep into the coax. Regarding twisted pair, I think it's just something that we like to clarify, since many of our clients are familiar with DSL technologies and what they call port bonding, you know, the bonding of two ports together to increase your speed or your distance. What we're talking about with the MIMO capability is bonding 2 pairs to a single port. We're not having to occupy 2 ports to do this. We're just, again, bonding 2 pairs to a single port. Just want to make that distinction. Thanks, Jim.
Yeah, thank you, Lyle. Yeah, to be clear, we've got 4-port, 8-port, 12-port, and 24-port GAMs, and it doesn't cost you a port. When you bond 2 twisted pairs together, you do it in an RJ45 port, you're using a single port, and as Lyle mentions, you're not, for example, turning a GAM24 into a GAM12 by using all MIMO. You get 24 ports of MIMO out of a 24-port GAM. You get 12 ports of MIMO out of a 12-port GAM. With coax, it's an F-type connector, and I'll show it to you in a moment. And you get to split that F-type connector up to 16 times, so you can provide multiple subscribers over a single coax and share the bandwidth along that port to every subscriber. And you can give them all a symmetric gig rate profile if you desire. Just got to watch your oversubscription ratio. None of them will really know that they're sharing with anybody else unless they're all trying to do a speed test at the same time. We can go 1,000 feet on RG59. That's the traditional cable that cable companies put in over the years in these buildings. I'm sure some of the newer buildings are going to have RG6. In that case, we can push a gig over 2,500 feet. And then if they're using RG11, we can push a gig over 3,500 feet. We've done some RV parks and trailer parks and so forth with that really thick cable, coaxial cable that's buried, and then we can go about a mile on with a gigabit service. So where would you use the GAM, and why would you use it? Well, because bringing fiber to every door in a brownfield MDU sometimes breaks the business case. It makes it harder to get your return on investment. If you are not in a 100% winner-take-all scenario, you're putting fiber into every unit with some sort of assumption around the take rate. Regulatory rules in this country now are geared towards benefit for the subscriber. And for that reason, the facilities that you put in they will eventually become the property of the landlord, not the property of the service provider. Already, all that old copper twisted pair that the telcos put in and all the old cable, coax cable that the cable companies put in is typically owned by the landlord. Now, some deals are still in place, some time-based deals where Comcast or Charter or somebody did a deal where they, for the next 5 years, they're the sole provider. The FCC is not looking upon those sorts of deals with favor anymore, though, because they know that what that means is that inside the premises, the subscriber doesn't have competition. So why would Comcast or Charter try to really provide good service. So the FCC's rulings around this are now favoring competition. The facilities will be owned, even if you put fiber in today, at some point in the future, it's going to be owned by the landlord. So make sure you design your return on investment if you put the fiber in around getting your money back before the ownership switches over. I'll mention again that our GAM eliminates the cost, the time, and the mess of the rewiring. It accelerates profitability. It shortens the payback period. And it eliminates truck rolls, hooking up new subscribers, because you're either going to rewire the whole building at once, because it doesn't make a lot of sense to go back over and over again and rewire the building. The other thing you want to know about the GAM is it meets tenant broadband expectations. When my daughter moved to St. Louis to work for Boeing and had to live in an apartment during COVID, what do you think her first question she asked the landlords? Not about whether there was an in-unit washer and dryer, but what are your choices for broadband? I'm going to have symmetric. I'm going to have to work at home sometimes. I'm getting my master's degree with Boeing. I'm going to have to do school at home. I need bandwidth, and that was more important to her than most other features that an apartment would provide. So those are the questions she asked. The other strength of the GAM, of course, is it leverages that existing brownfield multi-dwelling unit wiring. It accelerates your time to market, and your cost is lower. And the apartment owner themselves, if they have better broadband options, their real estate value increases. They get more renters, they get more condos and townhomes purchased, because those owners don't have to worry about their broadband. Now, where would you deploy it? Garden style apartments, mid-rise and high-rise apartments, duplexes, quads, all sorts of residential MDU applications rely upon the GAM today. Business mixed-use environments, we made sure to use Metro Ethernet Forum compliant components inside the GAM. So you can have the mixed use, you can have business campuses, you can have mid-rise and high-rise corporate. It all works for us, coax or copper. And then another big segment is resorts and hospitality, motels and hotels. And we've got a 100 megabit cable modem feeding us at a La Quinta Inn in Dalton, Georgia. And we've got a gigabit to 10 gigabits being served to us in Marriott and Barbados. We also are, as I mentioned, do outdoor entertainment venues, better guest entertainment venues at an RV park, for example. Retirement homes and assisted living are big customers of the GAM when they don't want to remodel every room. Barracks, military bases are deploying the GAM, airports, hospitals, and other types of MDU, MTU environments, just to give you a few samples. Here's what the multiplexer looks like. Every single one of these is designed either for copper twisted pair with the RJ45 connector or coax with the F-type connector. Every single one has 1.7 gig extended from each port. Every single one has a built-in non-blocking Ethernet switch to take, the Ethernet coming in and convert it to G.hn out, and then an endpoint will convert it back to Ethernet at the other end. Every one of these multiplexers has an agnostic, at least one, you can see two on the indoor units, up to 10 gig SFP plus slots, so you can put copper, or fiber, active or passive. We've also got some OMCI partners like Calix that we've done back office integration with their XGS-PON, so you can put a custom SFP in there as well. So we're transport agnostic. We've got the non-blocking Ethernet switch. We can support small, medium, and large applications. And on the next slide, you'll see the rest of the product family, which is indoor or outdoor with multiple power options.
Hey, Jim, let me break in. Our third-party SFP Plus supported in the game?
Absolutely. It's completely agnostic, and you can get those SFP Pluses, I think, from Core or just about anywhere. The only custom one that we use to date is the Calix XGS-PON sort of ONT on a stick, that we're going to be trying to do that with every XGS PON vendor so that we can be a multi-port ONT for them. But outside of that, you can drop us Ethernet from anything. It can be copper, fiber, active, or passive. All right, this is the entire product family. You can see you saw a magnified view of the indoor multiplexers on the last slide. We have 12 and 24 ports, copper or coax. We have an outdoor unit that has as many as 4 ports or 8 ports on it. You can see the 4-port coax unit here. Dimensions are 8 by 12 by 3. It's IP68. It's submersible. It mounts in a pedestal or on an inside wall, an outside wall, a pole, whatever you like. The 4-port happens to be less expensive than the 12, so get it just because it's cheaper, if you like. And then each one of the GAMs has their associated endpoints. We have a simple endpoint that simply takes the G.hn in and converts it, excuse me, to Ethernet for residential gateway. It's got 14 VLAN, single Ethernet port, but we've got more complicated, more premium endpoints that have thousands of VLANs for hooking up to, let's say you're in a hotel motel environment and you want to link the GAM through its endpoint to a Wi-Fi access point which serves more than one room in the hotel. Got thousands of VLANs, multiple Ethernet ports. We've got that model. That'll be the 1002 models. We've got a model that provides PoE out, so you can do 802.3 AF or AT. That's 15 watts or 30 watts, and that means you can power the Wi-Fi access point or a set-top box with it. As long as you plug it in first, it can power another device beyond itself. And if the GAM doesn't have power, we've got a unit that provides reverse power from the unit where it's plugged in back to the GAM over coax or copper twisted pair, so that you don't need to drop power to this 4 or 8-port GAM. These units, yes, sir.
Couple of questions that kind of came up during our recent TEL forum in Columbia, Missouri, that were kind of more common applications. So the first, you were talking about Wi-Fi. Which endpoints would you most recommend for those Wi-Fi where you want to also provide power extended to a Wi-Fi access point? Are those the 102 series?
Yes, it's the 1002 and the 2002. Anything with a plus. The plus means PoE plus, and that way you can power an external device.
And then the other common application, while we're looking at the endpoints, is in a coaxial facility where the client where the endpoint resides, the subscriber, where they don't have a power outlet where it's needed. What would be recommended in that application for endpoints?
You mean where there's no power outlet for the GAM?
Correct. For the endpoint.
The endpoints pretty much all plug in. There's one model, the G2002M Plus, that can be powered with a power injector next to the GAM. So you got one option that on copper twisted pair that where the endpoint can be powered, and we can do that on copper twisted pair. You can't do that on coax because you got the splitters going out, and you'd have to put power on every single one of those. Every one of those splits that end up having power on it. There's no safe way to do that. We can power reverse from coax or copper twisted pair with the MR and the CR. But in terms of power going out to the endpoint, so you don't have to plug it in, there's only one unit that does that. It's called the G2002M Plus. It's designed specifically so that you put a power injector next to the GAM that powers the copper twisted pair out to that end unit. That answer your question, Lyle?
Yeah, I think I may have misinterpreted a little bit the question, but you addressed both issues. I think the main application is where there's no power outlet, where the GAM controller is, and you addressed it with the reverse power endpoint. So thanks.
That's correct. You could do that on copper twisted pair or coax. Just have to use the one with the R on it. And then there's a similar unit, the CRX and the MRX, that's the GAM that you would use in that situation. So it's ready to accept power from the remote end of of the application. So I think we went over this slide pretty well. Now I want to just show you some basic applications. So this first slide is copper twisted pair, 96 subscribers. The internet is on the left. The transport medium, the backhaul, is in the middle. It connects up to a GAM. Then you stack 4 GAMs for 96 subscribers, 96 endpoints. If you had 24, you'd only need 1. If you had 48, you needed 2, so on and so forth. But convert it to G.hn, send it to an endpoint. Endpoint converts it back to Ethernet, drops it off to any Wi-Fi router of your choice. And when you do this, there is no construction. You just put the GAM in, connect it up to the wires that are already inside the building, and provide symmetric gigabit service to every subscriber. And you can do this indoor or outdoor. This application assumes more of a garden style environment where you've got a GAM on the outside of the building or in a doghouse next to the building, and you're reverse powering it. So there's not only data on the copper twisted pair going through the building, but now there's power feeding back to the GAM, so you don't need to plug the GAM in. And the way this works is every port is supported with an endpoint that provides power, and every port has the ability to power the commons and that port, so that no subscriber unplugging their endpoint can affect any other subscriber on the network. Coax is quite similar. Just notice fewer GAMs, more subscribers, right? With a single 24-port GAM or a 12-port GAM, you could support up to 120 subscribers because you're using splitters. And however the building's coaxial facilities are laid out, that's how you would lay out the GAM. If you're winning 100% of the building, it's easy. Just, bring all that coax over to the GAM, do all your fiber management, coaxial management in the telecom room, and you're done. Let's say you're in this to compete, one subscriber by subscriber. You simply take the coax that's connected to the coaxial, the cable company's facilities, put it on the GAM. You've won that customer. If you win that customer, you have to know which coax is going where, just like you'd know which copper twisted pair from the telco is going where. So if you go into a situation where you're competing, take one subscriber at a time and move them back over to the GAM and win that business away from the competition. And of course, the coaxial GAM supports reverse power, just as the copper twisted pair GAMs support reverse power, 1 per port. All right, so those are applications. Lyle, if you have any more application questions, I'll answer them now. But I was gonna jump next into software and partners and so forth.
Yeah, I think one of the things I'll just comment from Core's experience, with our experience with the GAM deployment is a lot of our clients have semi-standardized, especially where they have smaller count MDUs on the outdoor units, even if, because they don't know if they're going to have a space on an indoor closet, let's say. And so it's just easier not knowing what you're going to get to work with the outdoor units in terms of access. So that's one thing that we've seen a lot of our clients work with in terms of applications.
Thank you, Lyle. All right, so let's talk about software. So Positron, we've worked with enough companies over enough time to know that it's got to be multiple choice. And so we provide a whole bunch of different ways to manage our GAMs. One way is the command line interface. Keep in mind that there's an Ethernet switch built into every GAM, so that means you can manage it just as you would manage an Ethernet switch with the same syntax and scripts and so forth. That's free of charge, built into every GAM. It's a craft port on the left-hand side of the front of the GAM. You just plug in there and you use it, or you plug in using an IP address remotely. Every GAM also has a management port for a web-based graphical user interface. And I'll show you that in a minute, but it's, again, free of charge, available on every GAM and accessible through IP address. Then there's Virtuoso. This is the only one we charge for, and that's because it manages many, many GAMs, and we charge by the GAM to put it on the Virtuoso system. And it's got some advantages. It's got a tree and branch system, so you can get down from the network to the GAM you want to work with. You can do system-wide upgrades and all sorts of stuff with it that you would have to do individually with each GAM with the free GUI or Craftport interface. If you've got a custom back office, we do JSON and SNMP APIs and documentation, again, free of charge. Just download what you need, customize it, and integrate it into your back offices at your discretion. Then, finally, we have some partners. Billing and inventory platforms like RGNets, ETI, and Sonar already work with us today. And then we have completed our first XGS-PON back office integration with Calix, and we're looking to do the same with Ciena and Adtran and Nokia, DZS, and Core, and all of our customers will benefit from those back office integration efforts, because then your network operations center, in the case of Calix, for example, simply sees the GAM as a Calix multi-port ONT and provisions port by port through the Calix SMX software. Here's what the GUI looks like, tree and branch, access to the GAM's diagnostics, service monitoring, port configuration. Everything's built in and accessible locally or via IP address from remotely. And there's the standard command set for traditional Ethernet switch. You can use that as well. Here's the Calix interface. As long as you're using SMX, as I mentioned, instead of using a standards-based 1, 2, 5, 10 gig SFP plus, you'd use a Calix SFP plus. We call that the P-XGS-ONT-SFP. Essentially what it is it's an ONT on a stick. And once you put that in, then the Calix OLT sees our GAM as another Calix multiport ONT, and it's provisionable up to 24 subscribers. Any questions on software, partners, or anything like that come in, Lyle, before I go into support and wrap it up?
Yeah, Jim, I think from a clarification standpoint, you highlighted the SFP Plus that's compatible with the Calix SMX and XGS PON software loads. I guess I just want to emphasize that SFP Plus is actually a Positron part number. It's something you yes, purchase, from Core, from Positron. So, but in terms of, let's say today you had an Adtran, or you had a MDU that served with an Adtran or Desan Zone or Nokia ONT. What would that connection then look like to the GAM? I assume, is that just then an Ethernet Cat 5 or 6 cable connected to, a like SFP Plus interface for that copper?
That's correct. So you would use a standards-based SFP. It could be copper up to 10 gig. It could be less. Like I said, we've got a La Quinta Inn in Georgia served with a 100 megabit cable modem, but you could serve us with an Ethernet extension from an ONT. There's also an optical SFP that you can buy from us that you can hook GPON up to, and we've tested it with Adtran and Calix. You still have to use, I'm going to show you, you still have to use our GUI because it's not, it's not officially connected to Adtran or Calix or Nokia or DZS, but you can then support an optical connection from the ONT or the OLT into the GAM, and then use our GUI to manage that, or the Craftport. Does that answer your question, Lon?
Yeah, it sure does. I guess the other thing I'd like you to comment a little on, Jim, is we've got some experience with split ratios in terms of, you've highlighted that the maximum split ratio on coax is 16:1 per port, which is, I think, a G.hn technical specification. But in terms of, residential versus maybe hotel, do you have some recommended split ratios, that we've seen deployed to get the required speeds?
Yes. So in a hotel, I'll start with that first. In a hotel, usually what we see is 2, 3, 4 to 1. And usually what that means is we're not going to the room, we're going to a Wi-Fi access point, which is using wireless to serve multiple guest rooms. So that's most frequently what we see in hotels. The fact that you're splitting the service multiple times doesn't really matter, because hotels are typically satisfied with 100 meg. They're not trying to give every room a gig. A lot of times they're not giving them more than 10 meg. They're just trying to make sure that they have an adequate guest entertainment experience. In multi-dwelling units with individual subscribers like my daughter, they're going to do a speed test from time to time to see that they're getting what they paid for. If that's 500 meg, 300 meg, or if it's a full gig, they're going to test it from time to time. Mostly they're going to test it, though, if they sense some sort of a streaming experience that isn't working. They get some blur or pixelation, or maybe they're seeing latency on their gaming. So mostly they're testing you. If they see a service issue, then they're going to do a speed test. So we recommend for that, if you're going to serve everybody with symmetric gig, you want to make sure that you're not getting too many speed tests, because if everybody on the port tries to do a speed test at the same time, there's going to be some oversubscription. One person doing a speed test, though, shouldn't affect anything, because it's going to burst downstream up to 940, 950, and it's going to arbitrate quickly and go back to upstream and get up to 940 and 50. So they can see that they're getting what they paid for. And then it releases all of that bandwidth again, so it can be shared with all of the ports. So the only time that you ever get in trouble is if you put 8 or 10 or 12 or 16 subscribers on a single port, you provision them all symmetric gig and let them fight it out. Then you're probably going to see eventually, based on usage is going up over time, you might see two people trying to do a speed test at the same time, and that's going to be problematic. Today, as you know, as I know, I have a terrible service today. I have 300 megabit, which is satisfactory from Spectrum, but only that's downstream. I only have 10 meg up. So sometimes in these videos conferences, in webinars, I'm not getting my full 10 and things start to freeze. But what I know is having a household with 20 or more Internet of Things, like even the washer and dryer want to be hooked up to the Wi-Fi, right? Having multiple children using iPads and iPhones, having multiple TVs that are HD, I've never seen my usage get beyond 75 meg, and that's downstream. As I said, I exhaust the upstream all the time. That's why it's important to have symmetric speeds, 100, 100, or 300, 300. And so I know, and you know, that if you have 6 or 8 subscribers and you give them all 500 meg services, they're going to be perfectly happy, because normally they're going to be only using 100 meg. I think that was an overly long answer to your question, Lyle, but did I answer your question?
You did. I think just to summarize that in our experience, I think with residential, I think we've seen a, conservative, a 4-to-1 ratio, split ratio on the coax, and maybe 6-to-1 being more, kind of the mean in between, but up to 8-to-1 as well. But let me just clarify, we're talking about the coax split ratio between the GAM and the endpoints. We're not talking about the PON split ratio, which is a totally different issue.
Separate.
I just didn't want to confuse everyone with those two different splitter scenarios.
Yes, and then I did want to mention that we've got retirement homes, assisted living, and some digital divide, Section 8 type housing, where it's perfectly fine to do a 16 by split, because you're only giving them 50 meg each, and then there is no oversubscription. It's all dependent upon that rate profile that you want to give your subscriber.
And I think to be complete, if it's not obvious in the twisted pair scenario, ports and endpoints are in a 1-to-1 configuration. There's no split option with twisted pair. That's only for the coax facility.
Right. Twisted pair are all telephony home runs.
Again, if you do have questions, it's not too late to submit them on the question function at the top of the screen.
Okay. And then I'm going to just go into the summary real quick. We recommend premium support. You can have free 8x5 support all day long, every day during the weekdays, but you can purchase premium support through Core to get 24/7. You can purchase extended warranties on the GAMs. And that's pretty much it. If you need we discussed the GAN really at a high level, but it's a network solution. It does a lot of things. If you need a more personalized webinar, contact your Core representative and they'll get me on the line and we'll do a personalized presentation for you. That's it, Lyle.
Great, Jim. Thanks. I think if you want to contact Core on the chat function, I did put our general email box. Certainly, if you know who your regional salesperson or inside salesperson is, reach out to them directly. But otherwise, you can get me at sales@coretelecom.net, and we'll get it to the right person that serves you locally. With that, and I forgot, if anyone that was registered will be receiving a link to the recording as well as the slides presented today. So all of you will be getting those. So at this time, again, I'd like to thank everyone who joined us today. We know your time is valuable, and I hope you found this to be valuable in terms of your network and another tool you have for MDUs, which we know has been kind of a head scratcher for many of us as to what to do. And we also at Core have 2 or 3 folks who have a lot of MDU experience, actually work for operators who served MDUs. So, if you're just interested in what we've learned from that, and I think 2 of the guys actually spent some time doing some student housing, which is a whole nother animal in terms of needs, but because of that, they've seen a lot of different facilities and can maybe save you some time and headaches because they seem to be a puzzle in terms of rebuilding them. So again, thank you for joining us, and thank you again to Jim and the Positron Access team for their great partnership over the years. And from a Core Telecom perspective, I always welcome this opportunity to thank you all for your business and support of Core for 25 years. So with that, we're all done. I don't see any other questions. So with that, we'll sign off. Thanks again for joining, folks.
Thanks, everybody. Appreciate your time today. Thanks, Lyle.